Hello everyone. Today our topic is how to infer schema using sampling ratio. So whenever you read data set, so we'll use infer schema equal to true. So that time, if you mention infer schema equal to true, what will happen? Spark scans your data set, entire data set, to guess what data type has each column. But scanning the entire file can be slow for large data sets. So by default, Spark samples the first 1,000 rows to infer the schema. So this option, what is option called ratio? So this will see, so as of now, normally we'll see infer schema equal to true up to that. But today we'll see something new topic, sampling ratio, when to use this sampling ratio. So syntax is dot option sampling ratio, and the value we need to provide, that value is between 0 to 1. Suppose if you mention 0.1, so it is states that use 10% of rows for schema interface. So that means if we have total data frame, 1,000 rows, so it tells that use 10% of rows to infer the schema. So that means if we have 10 columns, to detect the data types for those 10 columns, it asking to use 10% of rows. Similar way, if you mention 1, then use 100%. So that is a default condition like full scan. Next, 0.01. So this use states that use only 1% of rows. So here we can see this option, dot option, sampling ratio as 0.1. So here 0.1 means 10% of rows. So this tells Spark to sample 10% of the rows. A higher ratio means more accuracy, but a longer leading time. So that means since we given 1.1%, so since it takes only 10% of rows means, so your accuracy will be less. But if you take 1 means 100%, then you will get more accuracy, but it will take longer time to load the data. So first we'll see for CSV file. So first condition is default behavior or full interface. That means no sampling ratio. So default behavior means infer schema equal to true. So Spark reads all rows to infer the schema. So this is most accurate, but it is slow for large data. So if your data set is very large, then if you try to do 100%, that means the default behavior, it will slow. That means reading the data set, it will take time. So first what I'm doing, I'm reading one CSV file here. So this is my catalog path. So here I have one CSV file called inferSchema. So here, what conditions here, what I mentioned is default behavior. So default behavior means dot option header equal to true, and the dot option infer schema equal to true. So infer schema equal to true means we are telling that to read entire data. That means reads all rows, full scan. And if you see, so here you will get data types. Once it read full scan, so you'll get based on the values, it will detect the data type. So next, using sample ratio equal to 0.1. So that means 10%. So what it means, Spark reads only 10% of the rows and it guesses the schema from that sample. So this is much faster because it's not reading entire data. So it's reading only 10% of the rows. So that's why it will be much faster. This is mainly useful, especially if the file is very large. So slightly higher chance of incorrect data type because you're reading only 10% of the rows. Suppose if you have other remaining 90% of the rows, if you have different data, then higher chances of detecting incorrect data type. So here what I'm doing, so I'm reading the data set from this particular catalog path. So CSV file name is inferSchema.csv. So here what I'm giving conditions, header equal to true, this is default condition, and option inferSchema equal to true. And additionally, what I'm giving is dot option sample ratio as 0.1. So this means it only take 10% rows to detect the inferred schema. So earlier case, what happened, if you mention only inferred schema equal to true, it will scan entire data. But here it will scan only 10% of the data and it will provide data types here. Okay, so the next one is small ratio, that is 1% for huge data set. So for getting performance gain, if you use 1% of sample ratio, so it will be 10 times faster schema interface. So risk is if your 1% sample does not contain all data patterns, so types of data types might be wrong. So here what doing is I'm mentioning sample ratio as 0.01. So that means 1% of the sample. So based on one sample, 1% sample, it will detect the data types. Okay, so next we'll see what is the difference between these three ratios. We'll compare the results. Suppose if I mention sampling ratio as 1, so how many percent, what is the percentage of rows scanned? That is 100%. So sampling ratio 1 means that is a default condition, that is inferSchema equal to true. So it will scan entire data. And here what is the code? Default no sampling ratio. That means if you're providing, suppose if you're providing this option, sampling ratio, that is 1. So if you're not providing this option, just mention inferSchema equal to true. So what it's telling is most accurate and speed is slowest. Suppose if you give 0.1, so that means it will scan only 10% of the rows, and how we need to write code is a dot option sampling ratio 0.1. So what is the accuracy is good balance, but sometimes less accurate if rare types exist. Suppose in remaining rows, if we have different types, since it is skip those rows, it may chances to get less accurate. But speed wise, it is fast. Next, suppose we are mentioning sample ratio as 0.01. So that means 1% of the rows scanned. So that means dot option sampling ratio as 0.01. So since it is scanning only 1%, accuracy will be less. That means it may misinfer some types. So that means detecting data types, sometimes it will get mismatch, but it is fastest. Next, observe schema difference. So that means suppose I have one age column. And if you observe here, so first three are integer, and fourth one is null, and the last one is a decimal. Suppose if Spark samples only first three rows, so those are integers. So suppose you mentioned percentage, so maybe some 30% you mentioned, so that it will scanning only first three rows. So by scanning these three rows, what it detect? Data type as integer. So age is integer. So, but if you scan full data set, but in full data set, so we have 45.5. Then it should be double. Suppose if you scan full data set, you should be double. So like that, mismatch will be there. So what is the best practice recommendations are? So if you have small data set, that means less than 100 MB, so no sampling required. So that means sampling ratio is 1. Suppose if you have medium data set that is between 100 MB to 1 GB, so you can mention your sampling ratio as either 0.2 or 0.3. If your data set is large, that means greater than 1 GB, so it is recommended to mention sampling ratio as 0.05 to 0.1. So if your data set is very large, that means greater than somewhere 10 GB, then recommended sampling ratio as 0.01 or less. So as of now, we saw how to handle CSV files. That means how to mention sampling ratio for CSV files. Now we will go for JSON file. So Spark will sample 5% of this JSON file to determine column data types. That means option inferSchema equal to true, option sampling ratio as 0.05, and the JSON file is this one. So say similar like CSV file, you can mention the sampling ratio here. So only code I'm showing here. So this is whatever explained above, same thing will applicable for JSON also. Suppose in case of Parquet, we can ignore this option. Suppose for Parquet, this option has no effect because Parquet files already store schema in metadata. So we don't need to infer schema or sampling ratio. So these two options are not applicable for Parquet files. So if you mention while reading the Parquet file, if you mention dot option sampling ratio 0.1, so there is no effect on reading the files or scanning the files. So next we'll see when sampling ratio helps performance. Suppose you are generating a bigger data set. Suppose something like spark.range, range between 0 to 10 million. So here I'm using with column renamed. So if you use by default spark.range, if you run only this much code, it will generate data frame as single column with column name as ID. But what I'm doing is on top of that, I'm using with column rename ID to age. So finally, this data frame, what it has is single column with column name of age, and data will be 0 to 10 million. Okay, so this data I am writing as CSV file by keeping header equal to true. So now I want to read this full sampled schema interface. Suppose if I do full scan, it will get slow because it is huge data. So spark.read option header equal to true, option inferSchema equal to true. So inferSchema equal to true means it will scan entire data. So since data is large, so inferSchema equal to true means it will do full scan. So that's why it will be slow. Suppose if I mention 5% sample scan, then it will be faster. So here in options, I'm mentioning inferSchema as true and option sampling ratio as 0.05. So that means only 5% of the data it will scan for detecting data types. So now what is the result is no sampling ratio how much time it will take? 12 to 15 seconds. So accuracy will be 100%. So that means it will do full scan. Since it does full scan, 100% accurate. And suppose you mention sampling ratio somewhere 0.05, then interference time, it will take 3 to 4 seconds. So compared to here, this is somewhere 12 seconds, this is somewhere 3 seconds. So inference time is very less, but accuracy matters. So sampling ratio, if you're mentioning 0.01, that means 1%, it taking somewhere 1 or 2 seconds. But if you compare here and here, too much difference, time difference. But only thing is risk of mismatch of detecting mismatch of data sets. So by looking all these things, what is the best practice? So when file is large, you need quicker schema inference. So what is the best option? If you have file is large, then spark.read dot option header equal to true, option inferSchema equal to true, option sampling ratio as 0.1. Okay, so that's all about this video, how to define sampling ratio while reading the data frame and parallelly detecting the inferSchema data types of the column. If you really like this video, please like and subscribe. Thank you.